For centuries, people have looked at the night sky. Scientists came up with a theory that we know today as the Big Bang Theory. This theory attempted to answer important questions about the origin, development, and expansion of the universe. However, recent research has increased the complexity of the mystery. In 2023, NASA's James Webb Space Telescope is amazing. He identified the heavenly bodies as older than the Earth. This discovery has puzzled scientists and questioned the nature of the star that is longer than the universe. Does it question our current understanding of the universe? Do we need a new paradigm to understand this puzzle? These questions and more are answered in this video. If you want to be updated about the world and its environment, subscribe to our channel, like this video, and turn on the notification bell. About 200 light-years away, near the constellation Libra, is an ancient star called HD 140283. The star's incredible speed, HD 140283, at 44,483 kilometers per hour, is a sign much for its dramatic history. About 1 billion years ago, our Milky Way, which is still forming, merged with a dwarf galaxy that housed a star. However, the most surprising thing about HD 140283 is not its speed, but its age. This star is one of the oldest celestial bodies we have ever seen and is named after the biblical character Methuselah, who is said to have lived for 969 years. Initially, estimates put it at 16 billion years, but the latest estimate puts it at 14.46 billion years, with an error of 800 million years. This figure is a big puzzle because it is different from the age of the universe, which we estimate from observations of the microwave background for 13.8 billion years. The question arises, how can a star grow older than the universe itself, which at first glance is impossible? Questions have been raised about the age of the star, the accuracy of our dating methods, and the end of the true age of the universe, leading to further exploration of these mysteries. First, it should be understood that calculating the age of celestial bodies is a very difficult task. Stars like our Sun keep their temperature and size constant for billions of years, making it very difficult to determine their age. Astronomers rely on subtle changes in the brightness and color of stars over time, and compare these measurements to mathematical models that predict how those stars will evolve. An important clue to determining a star's age is its rotation rate. Over time, the stars slow down, just like the speed of a wheel due to friction. By comparing the rotation rates of stars of different ages, astronomers have developed mathematical relationships that allow them to estimate their ages using a technique called gyrochronology. The star of Methuselah is very old. In fact, it is the oldest star in the universe with an age that we can accurately determine. But never mind that if it is more than 2 billion years older than its environment, we can look at the problem from a different perspective. Isn't the world as young as scientists thought? It is very difficult to understand the magnitude of 13.8 billion years. If we were to summarize the entire history of the world in a blue calendar that is as loud as the most spectacular fireworks of the new year, the Earth would only join this world march at the end of age, since human history does not hold the last 10 seconds on December 31. Scientists determine the age of the universe by observing the moon from stars born hundreds of millions of years after the Big Bang. As the universe expands, a phenomenon known as redshift occurs. By evaluating the observed distance and the size of the universe, we estimate that it is 13.8 billion years old. However, recent discoveries by researchers at the University of Ottawa raised the possibility that the universe is significantly older, estimated to be about 26.7 billion years old. University of Ottawa physicist Professor Rendra Gupta presents a theory that merges Swiss astronomer Fritz Zwicky's 1929 theory with novel ideas. This theory suggests that protons lose energy during their journey over vast distances and times. Despite being in contradiction with observable data related to redshift, Gupta proposes that by allowing this theory to coexist with the expansion of the universe, we could reinterpret redshift as a hybrid phenomenon that is not exclusively due to the expansion. This reinterpretation would increase the estimate of the age of the universe and could offer explanations for long-standing cosmological questions as well as some recently raised by NASA. NASA's James Webb Space Telescope contributed to an estimate of 26.7 billion years. Gupta combines the tired light theory with the theory of evolutionary interactions from the first, proposed by physicist Paul Dirac, which suggests that interactions may have changed over time. It is important to note that scientists have revised the age of the Earth many times. For example, in the 1920s, Edwin Hubble said that the world was only 2 billion years old. However, over time our decisions have improved significantly and the world's age has doubled. The increase is significant as astronomers deepen their understanding of the age of the universe in Gupta's work. Whether we consider only 10 seconds of recorded human history, or 5 seconds in the span of the universe's time, it is undeniably an ancient and fascinating place. World. Its constant expansion is far beyond the preconceived notions of our age. Anyway, it's a wonderful view of our own galaxy, the Milky Way. Current measurements show that stars in the outer regions of our galaxy are much faster than stars in similar areas. There are two explanations for this phenomenon. One is that there is very little dark matter in our galaxy, the invisible substance that plays an important role in the formation of the universe. Another possibility is that our understanding of dark things, including how much there is in the world, is different than we think. The puzzle is based on data collected by European Space Agency satellites that provide detailed information on the locations of nearly 2 billion stars in the Milky Way. These data have forced astronomers to revise their assessment of the behavior of stars, especially for stars outside our galaxy. The velocity of the stars is an important parameter for calculating the mass of the galaxy because the gravitational force acting on each star depends on the mass of the galaxy as a whole. Based on data collected by the Gaia satellite, a recent study calculated that the combined mass of our galaxy, including gas, dust, stars and dark matter, is about 200,000 billion times the mass of our Sun. Although this figure is significant, it is 5 times lower than previous estimates. This is because the amount of visible matter in the Milky Way has not decreased significantly. The interpretation of this result may be less bleak than previously thought. However, measuring the mass of the galaxy is a very difficult task, which leads to uncertainty in the information collected by the Gaia satellite or in the newly developed analysis. We will keep you updated on the latest news to keep you informed. If you liked the video, remember to like and subscribe and you will see the next video.